Hello everyone, welcome to the 17th lecture in this series. This lecture is actually a continuation to the previous lecture. In the previous lecture, we were studying queue data structure and its implementation using arrays. And I was telling you the basic operations which we do on queues, namely NQ and DQ. And when we implement queue using arrays, specifically when we deal with NQ operation, it has the only limitation that we cannot go beyond the maximum size of the array. And when we talk of DQ operation, you know that the front pointer, the front variable usually keeps track of the first element of the queue, and as we delete more and more elements from the queue, the variable front would be advancing to the subsequent positions in the queue, and whatever positions that correspond to the elements that were deleted from the queue could never be reused, and that becomes one of the drawbacks of that implementation. In some implementations, when we do DQ operation, what we normally do is that we keep on shifting the elements one position downwards. So imagine that if we remove the first element of the queue, all the elements from the starting element till the last element would be shifted downwards by one position. So we intend to do that just because we could conserve some space with that we could conserve space with the array being available with us. But that shifting always poses additional computational complexity. So we were saying that all the operations, namely NQ and DQ, could be done in order of 1. But if we have to do that shifting, then this complexity would never be order of 1. It would depend on the number of elements, so it may go with order of n. So to avoid all these challenges, we have a solution which is implementing queue as a circular array. And now with this lecture, we are going to see how we can implement queue as a circular array in order to overcome the challenges we have with implementing queue using arrays, especially with respect to NQ and DQ operations. So the thing which we do with implementing queue as a circular array is that we do not fix one end of the queue at index 0. Earlier we were we were fixing the front to point to the 0th location, and that is why always after removing an element from the first position, we were shifting all the elements downwards by one position. And in order to overcome the challenges imposed by shifting operation, we think of having a circular array. The principle is that in a circular array, the array actually loops back to the first position. That is, the array loops around itself. Say for instance, if the last index is say n, and so the location preceding it would be n minus 1, and the location following it would be 0, right. So that is how we wrap around the available array. And if suppose we remove an element from the 0th position, so front would advance to the next position, that is, it will point to index 1. And if suppose I have reached the maximum limit, say n minus 1 in this case, then I won't say that the queue is full by this time. Rather, I can wrap around and even occupy the first position, which is free now just because we have removed an element from the queue. So that is the greatest advantage we get with looping an array around itself with the concept of circular array. So in this case, with the circular array, we always keep track of front and the rear at any point of time to perform insertion and deletion. So instead of sticking on to one position for front, that is pointing to index 0, always instead of front being pointing to index 0, here the front can move around the array, and we keep track of the position of front and rear when we perform deletion and insertion operation on this queue. So, this diagram very well explains the concept of circular array implementation of a queue. So, here you could see that we have indices from 0 to n minus 1. So, that is the size of the array, and here you could see that we have elements being present from index 3 to 7. So, we have 5 elements. So, that is what denoted by count. And you could see here the first element that has to be removed from the queue is at index 3, and so front is having a value of 3, and the last element of the queue is at index 7, and so further insertion can be made starting from position 8, and so rear is pointing to the next available free slot, which is 8. So, front is pointing to the element that has to be deleted, and rear is pointing to the next free slot available with that array. So, this is how we have a circular array. So, here the principle is that instead of stopping the addition of elements to the queue once we reach n minus 1, now we can proceed with adding elements just because the location 0, 1, 2 are free now, just because we have removed those elements from the queue. So, circular array helps in conserving the memory space. So, the space that have been let free out of deletion can now be reused with addition of elements. So, here you could see the position of the status of circular queue at one specific point of time. We have here the maximum number of elements in the queue is 100, and you could see that the array index spans from 0 to 99, and here as you see front, that marks the element to be deleted. So, front says its position is 98. So, this is the element that will be removed from queue next, and rear is at the location 2, which means it is the next free slot available for the element to be added to this circular queue. So, what we understand here is that with the earlier implementations, if with the earlier lecture we learnt how to implement queues using arrays, right. There the principle is that every time we add an element, we just check whether we have reached the maximum limit, and in this case our maximum limit should be 99. So, beyond which we do not proceed with adding the element, but instead we say that queue is full and stop the procedure. Whereas, with the circular queue, just because these locations are free for insertion, we keep track of the value for front. Front is at 98, which means all these locations from 0 to 97 are now available for our reuse. So, insertion can happen again with this implementation, and as such front keeps track of the element to be deleted. So, we have the value of 98 there. So, whenever we want to do a deletion there, we can perform deletion operation from this position. So, in this slide what you see is that the same example, here we have drawn the circular queue in a linear fashion. So, this was the arrangement we witnessed with the previous slide. So, we had the value for front as 98. So, this is the element that entered the queue first at this point of time, and we have elements from 98, 99, followed by that we have 0 and 1. So, here the array wraps up to the initial position 0, and hence the name circular array. And other than that, rear is at location 2, which means this is the next available free slot for a new element to get added to this queue implementation. Here there is one slight change we do while insertion and deletion operation on a queue. So, here with respect to array implementation of queue, what we did was we checked whether rear has not exceeded the maximum limit. So, here in the circular implementation, whenever we increment the value for rear while adding a new element to the queue, we also do a check that we do not exceed the array limits, but wrap up to the 0th position, or we wrap up to the first position of the queue. In order to ensure that, we check we doesn't exceed the array limits with this formula, that rear plus 1 mod q dot length. So, every time we assign the value of rear to be rear plus 1 mod q length. So, you know very well what the purpose of rear plus 1 is. So, rear plus 1 would normally denote the successive position or the successive free slot available for adding a new element. And we have this operation mod q length. So, the purpose is to ensure that we do not go beyond the limits, and once we have reached the maximum limits, it has to wrap down to the initial position, which is 0. For instance, let us consider that we have our q capacity is 5 and our rear position is 4. So, in this case, if I attempt to do a NQ operation, then I make a check that whether 4 plus 1, which is 5 mod 5. So, 5 mod 5 would result, the result would be 0. So, the value that is set for rear would be 0. So, it would never report that the queue is full, rather it would wrap around to the initial position to facilitate addition of the element to the queue if suppose the 0th index is free. So, here we have an example. We have some elements with the queue, and here you see the value for front. So, front is pointing to the index 2. So, it is the element to be removed, and rear is pointing to the index 1. So, it is the next available free slot with respect to this queue. So, altogether the queue has 4 spaces, and we have only one location left for a new element to be added to this queue. Now, I want to add one more element. So, if I add a new element to the queue, then what happens is that the available free slot would be used. So, we have put up the new element in that place. So, now rear is also pointing to 2. So, it means there are no more free locations with this array, and just because of that reason both front and rear have the same value. So, this situation denotes the queue is full and we can no more add elements to that queue. So, we have only one way of adding further elements to this queue. We have to expand the size of the array first, copy the elements back to the array, and then think of adding some more elements to the queue. So, here this is one way of expanding the size of the array or expanding the capacity of the array. So, this was our state. So, front and rear both were 2, and so we consider that the queue is full. Now, we want to provide room for some more elements to be added to the queue. So, what we do is that we try to expand the capacity of the array. So, here we have expanded the size of the array, and so as of now front is in 2. So, the order in which the elements have to be processed is 2, 3, 0 and 1. So, this is the order the items entered into the queue, and they have to be sent out in the same order, right. And here what we have done is, while expanding we have just copied the elements in the same locations, that is 0, 1, 2 and 3, and accordingly the variables also having the values, and we have doubled the size of the array. So, we have some more locations available for use for the further elements to be added to this queue. And this is another way of building the new array. So, here what we have done is, we have built a new array and copied the elements into contiguous locations beginning at location of front. So, front was pointing to 2. So, instead of wrapping around, we have just doubled the size of the array. So, we have put up all the elements starting from the position of front. So, we had 4 elements. In the new array, these elements are copied in positions starting from front like 2, 3, 4 and 5. So, that we revise the value for rear. So, hereafter the new element has to be placed in the 6th position, and so rear has a value of 6. So, while expanding the size of the array, we could consider both options, either to have it the same way as it was before expansion, or to revise the position of the elements so that the circular queue would now operate in the same fashion with the different size. And so here in this example what we see is that we have expanded the size of the array, but while copying the elements we just follow the same fashion as we do it for the first time. Like we are placing the elements in the first 4 locations of the array and revising the values of both front and rear in this case, with front having a value of 0 and rear having a value of 4. So while expanding the size of the array, we could choose options that is convenient for us, either doing it this way or the way which we saw with the previous slide. And this is the very important check which we have to make whenever we add a new element to the queue. Always instead of just incrementing the rear by 1, we need to check we don't go beyond the array limits but wrap around to the initial position. For that we do a modulo division by the maximum capacity. So that is what being shown here, and with this arrangement we have 5 elements in that queue, and so front is pointing to 0 and rear is holding a value of 5, which where 5 denotes the next free space available for an element to be added to this queue. Now we have a look at the algorithm for the implementation of a circular queue. There are slight changes in the algorithm which we have already seen for array implementation of queue. So here let us see the algorithm for NQ. So for NQ we need to pass the element to be added as argument. First we check if the queue is full. If the queue is full, then we have to expand the queue. So how we decide that the queue is full is that both front and rear would be pointing to the same location or position. That helps us to decide that the queue is full, and then we consider expanding the size of the queue. Expanding the queue means we are actually doubling the size of the queue and copying the elements to the new array. If the queue is not full, then we can do an addition, or add the elements to the queue, but we do a check whether we are not exceeding the size, and if we are about to exceed the size, then we wrap around to the 0th position and add that element in the designated position, and we keep track of the count of elements in the queue, and thereby we increment the value of count. Now let us see the algorithm for expanding the queue size. So let us consider the variable q. So we are actually doubling the size of the array. So whatever size it was, now we are just multiplying by a factor of 2, and initially we set the variable copied as 0. This variable is just to keep track of the elements being copied to the new array, and we have a variable named I. It marks as the index for the array q, and j is a variable that points to front. So it is the index of the next entry in the array q. So we keep on copying till we never exceed the value of count. So count is the count of elements available with the old array, right, and copied initially we have set to 0. So that many elements that are available with the old array, we are copying that to the new array. So we move the elements one by one from q to q, and every time as I move we increment I by 1, and we check whether we have not exceeded the array limits, and as soon as one element gets copied to the new array, we increment copied by 1. So we will be doing on we will be looping through this piece of code till all the elements are copied back to the new array. And at last we have to set the value for rear. Rear should be the value of count minus 1, and front is having a value of 0. So here with this algorithm, what we say is that we double the size of the array, we copy the elements starting from the first position of the array till the count of elements, and so front will have a value of 0 and rear will have a value of count minus 1, and we make new array q as the q hereafter. That is the last step which we do with this algorithm. And here you see the algorithm for dq. So as such, with whenever we do a deletion operation on the queue, we need to check whether the queue is empty or not. If empty, we will report an error. Otherwise, we fetch the element that is available at the front positions and decrement count by 1, and after that we have to advance front pointer. But while advancing the front pointer, we don't stop with just advancing, rather we check whether front also exceeds the maximum array limits, and if it is about to cross, then we wrap the front back to the 0th position, and so we have added this mod size of array there. And finally, we will be returning the element that is to be deleted. So, this is how we do implementation of queue using a circular array, and the very purpose of having a circular array is that we think of conserving the space which would otherwise go waste while we do a deletion operation on the array. So, whenever we do a deletion operation, some spaces in that array, initial positions in the array would be left blank, and as we reach the maximum limit, we will not be able to do addition of elements further into the queue. But circular array gives us the flexibility to wrap around to use the spaces that have been left free just because of deleting some elements from the queue. Thereby, we claim that with circular array implementation of queue, we could conserve memory space. So, to summarize what we have seen so far, with this lecture we saw another variation for implementation of queue using a circular array. So, the speciality here is that the rear end of the queue wraps back to the first position when the end of array is reached, and thereby we are able to make use of the spaces that are left free just because of carrying out deletion operation on the queue. And similar to having all the operations implemented, namely NQ, DQ on array implementation of queues, here also we can do the same operations but with a slight revision. So, whenever we do a NQ operation, instead of just incrementing the rear by 1, we increment rear by 1 and do a modulo division by the max capacity. So, this prevents us to go beyond the array limits, but to wrap to the first position while exceeding the array limits. And whenever we do a DQ operation, we just remove the element from the front and we will be advancing the front pointer. So, while incrementing the value of front by 1, we do make a check that we do not exceed the array bounds, but wrap around to the initial position. And with the help of this circular array implementation, the advantage which we gain is that it avoids shifting of elements to the first position, which we had been doing when we implement arrays using queue using arrays and when we perform a deletion operation. And in addition to NQ and DQ, while doing is full of and is empty of, we can have conditions put up this way, like when we do check whether the queue is full or not, we will be checking whether rear plus 1 capacity is equal to front. It means the queue size is the maximum queue size is reached. So, we were seeing with that example where both rear and front are having the same value, and at that point we said that we have reached the maximum size. So, similar to that, in order to check whether the queue is full or not, with circular array implementation, we check whether rear plus 1 mod capacity is equivalent to front. If so, we stop and we may have to double the size of the array. And in case if you want to check whether the queue is empty, then we will be checking as usual whether both front and rear have the same value. So, there are advantages which we gain with the circular array based implementation of queue. So, it ensures reuse of space, and it eliminates the need for shifting of elements during a DQ operation. And of course, when we talk of time complexity, it is the same as that we had for array implementation of queue. For NQ, DQ and peak operations, it is going to have a constant time which is order of 1, and there is no shifting of elements required with this kind of implementation. So, having seen both the implementations of array, one with an ordinary array and one with circular array implementation of queues, Let's have some questions to test how we have understood the concepts of queue with both the implementations, namely array and circular array. First is, what is the main difference between a regular array based queue and a circular array based queue? So, the main difference is that in a regular array based queue, always front will be pointing to 0th index and rear would be advancing by one position as more and more elements are added, and whenever we remove an element from the queue, we would be advancing front by one. And with the regular array based implementation of queue, always the spaces that were free because of deleting the element can never be reused, and if at all we have to think of reusing that space, we have to shift the elements to one position downwards. And whereas in case of circular based queue, it gives us the flexibility that we can wrap around to the first position once we reach the last or the maximum limit of the array, and thereby we avoid shifting of elements and also we conserve the space allotted with the array. And how do you check if a queue is full in a circular array implementation? It is very straightforward. So, here we check whether rear plus 1 mod capacity is equivalent to front. If so, we say that the queue is full. And here we have an option that if you want to add up more elements even after the queue is full, then we may have to expand the queue size. So, we will create a new array, copy the elements back to it, and then proceed with adding more elements to the queue. And what is the time complexity of NQ and DQ operations in a circular array implementation? So, with the circular array implementation of queue, even during insertion and deletion, there is no shifting of elements. So, they are going to take a constant amount of time, which is order of 1. And what happens during a DQ operation in a circular array implementation? So, in a DQ, when we do a DQ operation, we will advance front by 1. Not only that, we check whether front is crossing the array bounds. So, we check whether front plus 1 mod capacity. So, if we exceed the capacity, it helps to wrap around front to the first position. And what condition indicates an empty queue in both array and circular based queues? So, if both front and rear variables are -1, then it means the queue is empty. So, I hope you would have better understood the concepts of queue, its associated operations and its implementation using arrays and using circular arrays, and possibly with the next lecture we can study about the linked list implementation of queues. And thank you for watching.